Now, let me show you another example. Here, we want to integrate the function x times cosine x. So, if we are gonna use integration by part, we're gonna determine which expression is gonna be u and which expression gonna be dv. And keep in mind, dv always has the term dx, right? So, just like in the previous example, I will choose u to be different functions. So I will compare different choices to see which choice is the right one. Let's see. If I choose ux to be cosine x, that means the rest of this expression, which is x dx, this is gonna be dv, right? Okay. So let me write the formula over here, the formula for integration by parts. So after we determine these two terms, the first steps is to figure out, according to your choice, we figure out what is a du and what is a v, right? So to find out the du, we differentiate this function with respect to x. So therefore, we take the derivative to cosine x. So we can get this is a negative sine x. So therefore, du equals negative sine x times dx. Okay, and then we figure out vx. So vx, and to figure out vx, we integrate dv. So that means we integrate x dx. So we have x squared over 2. Okay, so now now according to this formula, this should be equal to ux times vx, which in our case is cosine x times x squared over 2. And minus the integral of vx times du, which is vx is x squared over 2 times du. Du we figure out is this term, is minus sine x dx. Now, at this point, let's take a look at our result. You will see, well, we generate another integral which is not easy to solve, right? Because here you have to solve for this integral x squared over 2, which seems much more complicated than this one, right? Because for this integral, at least the power of x is 1. There is a 2, right? So this tells me maybe this way is not good. Well, now let's see what about another way. What if I let u be x? So ux equals x, and therefore dv is gonna be cosine x dx. Okay, let's try this way. So it's the first step. We figure out the du, so we differentiate with respect to x. This gave us 1, right? So therefore, du equals dx. Okay, du equals dx. Now, to find the vx, we said we integrate dv. So we integrate cosine x dx. Now, the integral of cosine x is sine x. Right? Okay. So now, let's see. We found du, we found the vx. So this original integral x times cosine x dx. So the first term is u times v, right? U times v, which is x times what is v? Times sine x, and minus the integral of v times du. Now v is sine x. Now du is dx. Now this integral is easy, right? This integral is as minus cosine. So it's minus cosine x, right, plus c. So the answer is x times sine x plus cosine x plus c. Okay, now let me summarize what should we pay attention when we are doing integration by parts. So just like u substitution, this method, it doesn't work for any integrals. It doesn't work for any integrals. For some type of integrals, we must try different ways. And there is not a guarantee method for doing it. That means there is not a formula which tells you, okay, which part I should not be u and which part I should not be dv. No, there's no such method. And how can we do this? We practice, right? The more you practice, the more you'll be experienced. Okay, and the third thing is, remember, always make sure that the product u dv equals the original integral. Like here, once you determine your u and dv, no matter if it's right or wrong, no matter if this choice will work or not, at least you have to make sure the product of them is equal to the original integral, right? So cosine x times x dx equals this, right? Equals our original expression in the integral, or x times cosine x dx. This equals the original expression. And the last point is, do not be hurried to jump to this method. So this means when you are given an integral to solve, now you first think about, can we just use a power rule to solve this integral? That means, can we do some algebra to rewrite the function so we can use power rule? And if it doesn't work, then we think about, can we use a u substitution, right? And if u substitution doesn't work, then we consider to use the integration by parts. Okay.